So section 5.3 part 2, the graph of f of x, concavity, and the second derivative test. So we're learning something new. It's called concavity. All right, it says if the graph of f lies above all of its tangents on an interval, then it is called concave up on I. So I is the interval. In other words, f prime is increasing on the interval. So the derivative is increasing. So we're talking about the second derivative. It says if the graph of f lies below all of its tangents, then it's called concave down. Okay, I hate this definition. I think it's stupid. So I'll explain what it means. So concave up means that if I have like a curve like this, all of the tangents, if I draw in all the tangent lines, do you see how they would have to be below the curve? Okay, that's concave up. Some people say that it holds water, right? It's like a bowl that's holding water. So if I filled it with water, it would hold it. Yes. But then there's concave down. Concave down looks like this. All of its tangents lie above the curve. Concave down. So it does not hold water. The water would fall out, right? Does this make sense? Now, I personally don't really like the holding water thing either, because you could have curves that look like this. That doesn't hold water, right? That water is just going to fly right down that curve, right? If it was 1 over x. But that is actually what we would call concave up. Does this make sense? So you really do have to kind of go back to the tangent line definition, although I think the tangent line definition is very confusing, thinking about it. Okay, so if you have a curve, so I'll just draw it down here. So let's say I have this curve, like that, draw a random curve. Can you tell kind of where it changes concavity? Yeah. Okay, it's concave down, and then all of a sudden, right around here, it changes to concave up. And then all of a sudden, right around there, it changes to concave down until like right around there. And then it changes to concave up. Do you guys see these little like places where it's changing?
Well, that's just like what if it doesn't? It doesn't have to change right there.
It's probably not exactly right there, but there's going to be a way that we find it. These are called points of inflection. Or inflection points. Points of inflection, inflection points. Okay, so we find these points by using the second derivative. Okay, so it says concavity test. It says if f double prime of x is positive, so greater than 0, for all x in the interval, then the graph of f is concave up. So positive, up. If it's negative, so f double prime is negative, then it's concave down. So on these problems, we're not only going to find the first derivative to find maximums and minimums, increasing and decreasing. We're going to find the second derivative to find where it changes in concavity. Okay. So the second derivative test, it's kind of confusing because the second derivative test actually involves the second derivative and the first derivative. So it should really be called the first and second derivative test. This is involving both of them. But we call it the second derivative test. So on your exam, if you say, this is true by the second derivative test, this is what it is. So it's important. They like to sneak this one in on the test too. So it says if f prime is equal to 0, and f double prime at that same point is greater than 0, then what? Does anybody have any ideas? So if your first derivative is 0, but your second derivative is positive, what do you have at that point? It'd be concave up because the second derivative is positive. But then if your first derivative is equal to 0, it's a minimum. Yes, do you guys see it? Because you're going concave up, but your first derivative is equal to 0, so it's a minimum. Oops, extra m. All right, so same idea. This one says if f prime is equal to 0 and f double prime is negative, so the second derivative is negative, so it means the graph of f is concave down, then f has a maximum. So like I said, they like to put these on the AP test. They just put them in like a multiple choice, and you're like, what? What's going on? And then you're like, oh, second derivative test. So you gotta know this one. Note cards. All right. Next up. So it says determine where the graph of f of x equals x to the fourth minus 6x squared plus 1 is concave up and concave down. Find any inflection points and draw a graph. So we're going to find everything there is to know about this graph. Yes, I know. So we're going to do f prime. So I get 4x cubed minus 12x. And I'm going to do f double prime as well. I'm going to do it next to it because I'm going to find when f prime is equal to 0 in a second. So f double prime is going to be 12x squared minus 12. And I want to find when both of them are equal to 0. So on the first one, for f prime, I can pull out the common factor, which is 4x. And I'm left with x squared minus 3. So I have 4x is equal to 0. I have x squared minus 3 is equal to 0. So I get x equals 0. And I get x equals plus or minus the square root of 3. Don't forget your plus or minus. So those would then be the things that I would put on my f prime number line. So I put 0, I put negative root 3, and I put positive root 3. Okay, then I decide if f prime is positive or negative on each of those intervals. So I'm going to plug in, let's see, negative 2 into the derivative. I'm going to plug into this right here. So if I plug in negative 2, I have a negative number, and then I have a positive number. So I multiply and get a negative. If I plug in negative 1, I get a negative number, I get a negative number, multiply, I get a positive. If I have a 1, I get a positive, and I get a negative, so I get a negative. And if I plug in 2, I get a positive, and then I get a positive, so I get a positive. It's saying that the graph of f is going down, up, down, up. Always think, does that make sense for the original?
Yeah.
Yeah, it's an x to the fourth, right? It's a W shape. Okay, now let's do f double prime. So f double prime I set equal to 0. I pull out the common factor, which is 12. I have x squared minus 1. I can't do 12 equals to 0, so I do x squared minus 1 equals 0. In other words, I can factor x plus 1, x minus 1. So I get x equals plus or minus 1. I now do a second number line. But now this is f double prime. This is why it's important that you label. And plus, on the AP test, they don't grade those number lines, right? So you guys know you have to write what's in those if you were going to use them. All right, so I have negative 1 and 1. But now I'm going to plug into f double prime. So I'm going to plug in, let's see, negative 2, and I'll plug it into this one right here. So when I plug in negative 2, I get 12 times a negative number times a negative number, so I get a positive number. When I plug in 0, I get 12 times positive times negative, so I get a negative. And when I try 2, I get 12, positive, positive, positive. And I don't do my little arrows this time, I do something different. Okay, if it's concave up, right, second derivative is positive, I do like an up like that. Concave down, down. Concave up, up. Right, I put like little U's. Does that make sense based on the graph?
Yeah.
Right, up, down, up, if it's a W shape. It makes sense, so we're good. All right, but we just found the places where there is a point of inflection. A point of inflection occurs when it changes in concavity, when it goes from up to down or down to up. Okay, if it just went up to up, it's not going to be a point of inflection. Okay, does this make sense? So you have to change in concavity. Okay, so we do have to draw a graph, don't we? Oh, fun. All right, so let's find these important values. So let's find f of negative square root of 3, f of 0, f of square root of 3. And we're also going to find the other ones, f of negative 1 and f of 1. Those are going to be our inflection points. So let's do the 0 one first. That's always the easiest. I get 1. How about 1 and negative 1? When I plug in 1, I get 1 minus 6 plus 1, negative 4. Did you guys see you'll get exactly the same thing for negative 1? Yeah, it's an even function. Right, everything has an even power. So it's symmetric across the y-axis. If I do square root of 3, I get square root of 3 to the 4th minus 6 times square root of 3 squared plus 1. Square root of 3 to the 4th, what's that? 3 squared, which is 9. So you have 9 minus 6 times 3 is 18 plus 1. So negative 9 plus 1 is negative 8. You get the same thing for negative root 3. So this is taking like you're graphing from algebra 2 to another level. Like not only are you finding like the zeros, right? You can find the zeros of this if you want to. We're finding like maximums, minimums, inflection points. We're finding everything there is to know about this graph. Okay, so I'm going to have 0, 1. That's my first point. And that's going to be we said that was a max. So sometimes I like to do like a little like bump there. So I remember, okay, that's a max one. All right, and then I have, let's go with the square root of 3. Square root of 3 is around 1.7. So I'm going to have negative square root of 3, comma, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Just right around there. And then square root of 3, comma, negative 8 as well. So those are going to be minimums. And then I have negative 1, negative 4. And I have negative 1, sorry, I did 1, negative 4. And I have 1, negative 4 as well. So both 1. Okay, and those are inflection points. So sometimes I do like little stars or something. So I remember those aren't minimums. So you can do whatever you want. Right, and then it just goes up. It's where it's changing from concave up to concave down. Okay. And then you would label each of those.
So basically what you're doing for like the reasoning why you're finding the second derivative is because you're trying to find like the slope between like the slope of the or I guess where
you're trying to find where the rate of change changes. So it's kind of weird. You're finding where the slope of f prime changes. Yeah. Well, yeah, slope of f prime is 0. Yeah. So where it changes from like positive, negative, or whatever. Yeah. So like an application of this, so people are like, when did we ever use this? Let's say you're selling a product. So I'm selling something for Christmas. It makes me think of like back in my day, it was like Elmo, Tickle Me Elmo. When Tickle Me Elmo came out, it was like a big thing. You guys were probably kids then, I guess. You guys did you have a Tickle Me Elmo?
No.
Okay, so when the Tickle Me Elmo came out, it was like a huge thing, and like parents were fighting about getting this Tickle Me Elmo for their kid for Christmas. But the point of inflection is where the sales are still, like they're still positive. You're still selling a lot of them, but it's where it starts to like decline in the rate. Does that make sense? So like, yes, things can go positive, but if they're like that, yeah, you're still selling some, but you're starting to decrease the rate that you're selling. Okay, so then that's when you would like do like a price drop or something like that. Does this make sense? Okay, so that's an application. All right. Okay, so sketch a graph of the curve, labeling all points of inflection in extreme. I got kind of lazy. I didn't label the last one. So same thing. So we're going to go with y prime. So I get 4x cubed minus 12x squared. And I have y double prime, which is 12x. Is this the same one? Did I just do this one? Okay. What? Oh, there's no plus 1, but it's basically the same.
Yeah.
Nah, well, oh, well, it's 6. Yeah, they're different. They're different, okay. So I get 4x cubed minus 12x squared. And then y double prime is going to be 12x squared minus 24x. So there's probably a reason I chose this one. All right, so this first one, I'm going to find when it's equal to 0. So I'm going to pull out a 4x squared. And I'm going to have an x minus 3. So I'm going to have x equals 0, and I'm going to have x equals 3. So when you do your number line, this one's going to be a little bit different. Because 0 had multiplicity. Do you guys see it? Like 0 was an answer twice to that. When that happens, there's probably going to, it's not going to like alternate. It's not going to be like plus minus plus. Okay, so there's going to be something strange that happens. So if I plug in a negative 1, I get 4 times negative 1 squared is 1 times a negative number. So I get a negative number. When I plug in 1, do you guys see that you get a negative number as well? Okay, when I plug in 4, I get a positive. So it's going down, down, up. So it's saying that the shape of the curve is like this. So in the middle, it tapers off to a slope of 0. Like at 0, it's tapering off to a slope of 0. But it's still going down. It's still decreasing. Okay. Now the next one. So if I set y double prime equal to 0, I pull out a 12x. I have x minus 2. So I get x equals 0 and x equals 2. Okay, so when I plug into y double prime, if I plug in a negative, I get a negative times negative as a positive. So I plug in 1, I get positive times negative as a negative. If I plug in 3, I get positive. So it's concave up, then concave down, then concave up. Does it look like that based on my little sketch that I just did? Yeah. Yeah. See where it's turning. So this point right here is, it's not a maximum or a minimum, but it's an inflection point. You can see it was on both of these graphs. So it wasn't a max or min, but it's an inflection point. So it's a critical value that's not a max or min. So it's a critical value and an inflection point. Okay. So if we graph it, we need to find all these different values. So I need to find f of 0, f of 3, and then I only have one other one, f of 2, right? F of 0, that's easy, it's 0. Right, plugging into the original. I shouldn't say f. I failed as an AP Calc test taker because I've never called this f, so why am I all of a sudden talking about f of 0? I shouldn't do that. I know, you're confused on what function I'm talking about, aren't you? So I'll say y. Or you could write at some place, you could say let f of x equal, and then the original function, right? F of x equal y. Yeah. All right, 3. You laugh and say that's dumb that you have to do that, but you miss points on your AP Calc test from this. All right, now I'm going to be sneaky and I'm going to pull out the common factor, which is 3 cubed. So I'm going to have 3 minus 4 left. So I know it's negative 27. I didn't want to find 3 to the 4th and then subtract out. Use my math skills. All right, and then squared. So I'm going to have 2 to the 4th minus 4 times 2 cubed. I could do the same thing, like 2 cubed. So I'm going to have 2 minus 4. So 8 times negative 2. So negative 16. Yeah, fun tricks. All right, so 0, 0. That's the place that's a critical value and an inflection point, but not a max or min. And then you have 3 comma negative 27. Yeah, that's when you just put it like down there. All right, and then 2 comma negative 16. Okay, so the 3 comma negative 27, that was going to be my minimum, so I would probably do like a little bump there, just so I know that's as far down as it goes.
0 is the maximum?
It's not. You have to be careful. That's the place where it's like, it's doing like that little squiggle, like the x cubed graph. So it's like that. Now, based on your Algebra 2 knowledge, because you all remember 2 years ago when you took my class, right, Algebra 2, you can pull out an x cubed. Like if I was finding the zeros of that, like the x-intercepts, I'd pull out an x cubed, and then I'd have x minus 4 left, right? That means that x equals 0 is a 0 of multiplicity 3. Do you guys see it? So that's why it makes that little bend there. So you could have graphed that without even any calculus, except you wouldn't be able to find the minimum. Okay. All right, next step. So it says sketch a graph of the function having the given characteristics. So it's saying f of 2 and f of 4 are both equal to 0. So I like it when I'm given points at the beginning. So f of 2 is 0. F of 4 is 0. It's saying f prime is greater than 0 if x is less than 3. So that's when I like think about a number line for f prime. I'm saying it's greater than 0 if x is less than 3. So it's positive over here. F prime of 3 does not exist. D and E. F prime of x is less than 0 if x is greater than 3. And f double prime is positive for everything except for 3. So at 3, it probably, I don't know if it does not exist or what. Something happening there. Positive, oh, positive. Oh, could have gotten a bonus point. So speedy. All right, so when I have these little charts drawn out, it means it's increasing and then decreasing for f prime. So when I say that, the graph of f is increasing or decreasing because f prime is positive. You have to be very careful with what you say. All right, and then f double prime is positive, so f is concave up and concave up. It's got to go through those points too. Okay, what do you think? Anyone have any ideas? You could do a corner. Not really a corner though, because that would be straight lines. It's not really straight lines. A cusp, yeah. So you could do something like maybe there's a point here, and you go through those two things, like the 2 points. That would work.
That's what I meant.
Yeah. What else could you do?
We'll just do the y by 3 right there.
We don't know. Whatever. It could be an asymptote. So this would be another thing that would work. 1, 2, 3. Asymptote through that point. Through that point. What's the question, Randy?
How did you?
Because we knew that f prime did not exist at 3. Okay, so it couldn't have been like a max or a min or anything like that. There had to be either a corner, a cusp, or an asymptote there, because the derivative didn't exist. Yeah, so those are the 2 solutions you could have, something like that. Does that make sense? Yeah. All right, any others? That's it. Because it said f prime of 3 does not exist. Do you see it? I just guessed.
Right.